Hi, welcome to the Unit 2.1c Solution Chemistry video. This is part one of two parts where we're going to explore the first half of the second key question, which is how do we describe both qualitatively and quantitatively what happens during the solution. Please be sure to annotate appropriately as you watch this video. Okay, so in the previous video, notes, which is a note video for 2.1b, we started to explore the process of dissolution, which is the process by which something dissolves. And one of the things that we discussed is what happens when something dissolves depends on the substance. And here at the bottom, we have a table. We have ionic compounds, and those are broken down into salts and bases. Remember, ionic bases are metal hydroxides. And we also have molecular covalent compounds. We have acids, which are recognized by the hydrogen in the front or the Cu group, molecular bases, which are amines, and polar molecules. And these are sort of color-coded based on what happens. So let's start looking at the things that are color-coded here in this light blue color, which are our ionic compounds and our acids. So what happens when we dissolve ionic compounds and acids? What's going to happen is that they're going to ionize, meaning that they're going to break apart into ions when dissolved. And there are two types of ions that we get, and we get anions and cations. So for salts, the anion will be the metal and the anion will be the nonmetal. When you have a base, it's going to be the metal and the hydroxide, which is a nonmetal. And essentially, this base is a salt, but we are going to consider it as a base because of some of its special properties. For acids, when they ionize, they break apart into the proton, which is the H+, and then whatever is left is the anion. Now, the extent of ionization is determined by the solubility of the salt and the strength of the acid and base. So remember, if you have a soluble salt, all of it will completely ionize or break apart into ions. But if you have a slightly soluble or an insoluble salt, only some of it will break apart. The same thing for the acids and bases. If you have a strong acid or base, they're going to completely ionize. And if you have a weak acid or base, it will only partially ionize. All right, the next thing we're going to look at are the molecular bases, which are the amines. So these will dissolve in water, but they don't break apart into ions the way salts, bases, and acids do. What happens is that they need to react with water. So you have to react this amine with water in order for it to form ions. And so that's something that's unique. And when we write its dissolution reaction, unlike for the other dissolution reactions, we always add H2O on the reactant side. For polar molecules, they dissolve in water, but they do not form ions at all. And so remember, in this case, instead of ionizing and breaking apart into ions, they sort of just break apart into, if you have a big chunk of sugar, for example, it'll just break down into smaller chunks of sugar, but the sugar itself will remain sugar. All right. Next thing we're going to talk about in terms of guidelines for writing reactions are the phases, and specifically the phases of the reactants, because I believe in the last video there were several mistakes and things were not made clear. So let's start off with ionic compounds. So ionic compounds, whether they're salts or bases, those reactants will always be written as a solid. And so here are some examples. If you're looking at the ionization of NaCl, you indicate that that's a solid. It starts off as a solid and breaks down into aqueous products. Same thing with sodium hydroxide, which is an ionic base. It starts off as a solid and it breaks down into its respective aqueous ions. Here we have some examples of a slightly soluble or insoluble salt, which is silver chloride. Again, it starts off as a solid, breaks down into its aqueous ions. And then for magnesium hydroxide, which is a weak base, a weak ionic base, starts off as a solid, breaks down into its aqueous compounds. On the other hand, when we're looking at molecular covalent reactants, and that would include both the molecular bases and the acids, what we find is that the reactants are going to start in an aqueous form. So for anything in this box here, on the molecular covalent box, they start off at aqueous. And we see that with HCl, its reactant is actually aqueous. And then it breaks down into aqueous ions. In H3, it's aqueous. And of course, because this is a molecular base, one of our other reactants will be water, H2O, and that's a liquid. So we start off with an aqueous NH3, reacts with water, and it forms two aqueous ions. The last example here, this is actually vinegar, acetic acid, starts off as aqueous and breaks down to aqueous ions. So sort of to recap, on this side, with the ionic compounds, we have our solids, and on this side, our reactant starts off as aqueous. All right, so now that you've seen that example, you're going to write the equation for the ionizations of the species below, A through E. I want you to make sure that you consider the type of compound to know if you should use S or aqueous for the reactant phase. And also the solubility rules to know if it completely ionizes, and if it does, you use a single arrow, or if it does not. You also, if it's an acid or base, you want to consider the strength, again, to know if it completely ionizes or it does not. So if you need to, you might want to go back to your previous note packet to review the solubility rules and the list of strong acids and strong bases. You can pause this video now. When you press play again, the answer will be revealed. Okay, so you can take a moment to check your answers. For the first one here, we have an amine, so it's going to, this is a molecular covalent compound, so that's going to start off as aqueous, and it's going to react with water to form its ammonium salt and hydroxide. Here we have a group 1 salt, and remember all group 1s are soluble, so that's going to break apart completely into its ions. HF is a weak acid, so that's going to only slightly break apart into its ions. Barium hydroxide is a strong base, so it's going to completely break apart into its ions. H2SO4 is a strong acid, so it's going to completely break apart into its ions. But I want you to pause a moment to note that in this case, there are two hydrogens, two acidic protons in H2SO4. And when we break it apart one at a time. So I only removed one of the acidic protons, and its anion is H2SO4 minus. The corresponding anion is here. So this would be correct. If you wrote something like this, where you sort of broke it down apart completely all one step, that is incorrect. All right, so let's take a closer look at that. So what we're now looking at is guidelines for writing reactions for polyprotic acid. A polyprotic acid is an acid with more than one acidic proton, and H2SO4 is one example, H3PO4, H2S, those are some examples there. You can see they all have more than one acidic proton. So the key is to ionize one proton at a time. So if you take something like H2SO4, which is actually a strong acid, it's going to break apart into H plus and HSO4 minus. And then its HSO4 minus product, which is a weak acid, is going to then break apart into H plus and SO4 2 minus. So this occurs in two steps because there are two acidic protons. All right, so it's your turn now to write the ionization for H3PO4, which is a weak acid, if you do not recall. So you're going to try this out, and when you press play again, the answer will be revealed. All right, so H3PO4 has 3 acidic protons, so of course we should have about 3 steps. Here's the first one, there's the second one, and then there's the last one. So notice, again, we remove one hydrogen or acidic proton at a time. Okay, so that's it for part one. We're going to pause or stop this video, and then we're going to go on to continue on to part two. So have a quality day.